So Joel, you're welcome. Huh?
Okay, thank you.
I
Mhm.
gave you some task the other time, going
Yes,
over.
teacher.
Mm,
I've done it.
mm,
Eh, I had done it. Now, when I wanted to submit it
mm,
in to the site,
mm.
my internet still has a problem. So
Okay.
I was still connecting with Teacher Bernard to tell me
Mm,
how I can sort of
okay.
uh,
But
the
you will say,
internet.
mm, let
So
me.
when I put them, I think we shall be going on smoothly.
Oh,
Eh,
good. Now, but still, I think it is important. I have to explain few things here,
okay.
because this is a very important aspect, especially in practical physics.
Mm,
So, without knowing it, I think you will be having issues.
mm,
I also have challenges of network. There was things where it was very hard for me to go into the site, and then, in fact, accessing the site, even trying to share my network has issues. So what I'm going to do is, uh, I'm explaining already what you have there. Then you can
mm,
be listening,
mm.
but you can have a pen and you note down few things.
Yes, teacher, I'm
Yeah,
having them right now.
good. So all I wanted us to know was the concept of the significant figures. We To understand what these significant figures are, first of all, we need to know what these significant figures are. So we are saying these are digits in a number that are reliable
Mm.
and absolutely necessary to indicate the quantity of something.
Teacher,
Yes, please.
mm.
Am
It
I
says
going
that,
very fast?
you know,
Mm.
how do you see if I share what I scanned in your
You,
inbox, how can you help me
you,
to upload it in the site? Hmm?
can I help you to
To upload it on the site.
on the WhatsApp?
On the site. On
Uh,
okay, after.
Share this one. You will be that. No, I'm explaining this, but of
Okay.
course you have done the assignment. But I feel you have gone over it. I still need to explain this because I've given for you two tasks. The other one is this assignment. I think that one is trying to guide you on the other thing of um
Okay.
the other topic. We shall be moving concurrent like this. Once I get the concept on practical physics, then one at a time I get some concept on the theory. So we shall be moving like that. So this
Yes.
is a very important aspect in practical
Mm.
physics.
Yes.
Significant figures were saying there are numbers which are very reliable, or are digits which are very reliable, and they are absolutely necessary to indicate the quantity of something. It was on that slide I shared for you. I remember my
Mm.
presentation.
Yes. Yes.
Uh,
Yes.
a digit that are reliable and absolutely necessary to indicate the quantity of something.
Mm.
Uh, yes. So, which means there are some figures. For example, when I say 0, 1, 3, 5,
Mm.
I have started with 0. 0, 1, 3, 5.
Mm.
Do you think the first 0 there is reliable? Hmm?
Mm. Zero.
Do you think in my 0, uh-huh, when I have a number like 0, 1, 3,
Mm.
5,
35. Yes.
see, the first 0, uh,
Mm.
in other words, that 0 is useless. See, we cannot say that 0 is significant. It is because it is not reliable and it is absolutely unnecessary to indicate the
Mm.
quantity of that number we needed. Eh?
Mm. Yes.
Now,
Yes.
when we have another number,
Mm.
if now maybe the number is 106,
One, zero,
we
yes.
have another number now 106.
Six. Yes.
You get that?
Mm.
So you find that that 0 is in the middle.
Mm.
Hmm? We
Yes.
have that 0 is in the middle.
Mm.
That 0 becomes what? Very, very necessary. And then
Mm.
it is very important. So because it is very important, it carries on the value of that number. We shall say
Mm.
that 0 in the middle is significant.
Okay.
I want you to write it for me, this number, which this was what I had in my summary slide.
Yes.
The number is 0.00
0.00
508
508
30.
30. Yes.
Yes. So
So how many
you have,
significant?
we have no. I'm trying to, let me elaborate about something about this. We have that number 0.005080.
Yes.
The first three zeros, which are to the left, you can be rounding them. The first three zeros, which are to the left, those zeros, what do you call them? What do you call those first
The first,
three zeros to the left?
the first
Aha.
three zeros to the left.
Yes.
They are called a zero before a point is
Yeah.
is okay, is not significant, eh?
Aha.
And a zero after a point is significant. So there is some correction here. There is some little thing here. Because for me, I believe that a zero before a point is not significant. A zero before a point is not significant, because you have told me that it is not reliable, and it is not reliable and absolutely it shows unnecessary.
Value.
It is okay in form of unnecessary to indicate the quantity of something.
I get your point.
So meaning that for me, even me, I also at a point where I contradict with some things. Where you see that a zero after a point is significant. Yes? A zero after a point, we believe that it is significant.
Okay. So those zeros, what do you call them? I want that specific name given, the description given for them. The first three zeros. Those are
trading. Yes, they are called trading. We have trading, leading, and dropped zeros. They are called leading zeros.
Oh, good. They are called leading zeros. Those zeros that come before a non-zero digit, they are called leading zeros. But of course, we know now from there, we have non-zero digits. These non-zero digits are digits like 5 there, 8, and what? 3. Those are non-zero digits. Those first three zeros, you see, those first three zeros, those ones are called leading zeros.
Yes.
Then the last zero after 3 is called trailing.
Trailing zero.
You get it?
Yes, yes.
Trailing zero. So usually in examination, as far as performance is concerned, in class examinations, I mean examination you have at school, they can be saying you are trailing. Sometimes you even get commentators in football saying, this team is trailing, which means the team is what? Losing. Oh, it is when in terms of performance, when it is used in performance, we're saying you are the last. You are trailing, which means you are towards the last. So the trailing zeros are the zeros which are at the end. So of course, for non-zero digits, we know. Then leading zeros are those ones there. But now let us try to look at them in details. We're now saying here, we have non-zero digits. All non-zero digits are they significant or they are not significant? Non-zero digits. Can you give me examples? Because
non-zero digits. We have
examples of
1, we have 2, 3, 4, 5. Yes.
Now I just
up to 9. Yes. One up to 9.
I just said in short or in summary, figures that are formed from 1, 2, 3, 4, 5, 6, 7, 8, and 9. First of all, those non-zero digits are significant. Secondly, they are all significant. When you get a non-zero digit in any number, it is significant. So now the examples are, I'm saying 1, 2, 3, 4. You can mention up to 9.
Up to 9, yes.
Yes, those ones are all significant. Then The second example is any other figure which is formed from the above digits. I want you to give for me 4 examples of figures that can be formed from the above digits that we said are significant.
I form a figure which can be formed from the above digits.
Which we said was significant, from 1 to 9.
From 1 to 9.
I want you to form for me numbers, if I may be a little bit simpler.
Okay. We have like, let's say we have like 234.
Correct.
Those ones are lists of, okay, those ones are
234. Correct.
Yes, we have 356.
350. Correct.
356. So
that is, I wanted 4.
You wanted
from
4.
That.
So how do you see if I say like maybe like 2003 and 34?
2003. 2003.
2003. 2003.
I want digits formed out of the non-zero digits without zeros.
Yeah.
So from my slide, my slide there, you would get 546, which has 546, which has how many significant figures? 5 is the first one, 4 is the second one, 6 is the third one. Those are 3. We have 1,875.
1,875, yes. Those are 4.
Then we have 935,000.
935,000.
662. 935662.
935662. Those ones are 6 significant figures.
We have 1.238.
1.238. Those ones are 4 significant figures.
Very good. So when you just go to you find a number like this, non-zero digit, they are all significant. Is that okay? Have you got the point?
Are all significant.
Very good. Let's now go to zeros. We now have zeros. At the start, I told you I had given for you a number where you identify the zeros. We realized that these zeros are divided into 3. We have leading zeros. We have trapped zeros. And then we have trailing zeros. Is that okay? There are 3 types of zeros under significant figures, the description. Leading zeros, trapped zeros, and trailing zeros.
And trailing zeros,
yes. Then leading zeros. We shall say these leading zeros are zeros that precede. When we usually talk of that precede, we say that are before. Before non-zero digits.
Zeros that proceed.
Precede. Precede is PRECEDE. Yes, please.
They are zeros which proceed.
Precede, which means they are before. Not proceed, but precede. Precede. Which are before non-zero digits. I think it should be noting down major things. Otherwise, I'll be able to share for you this slide once again.
Okay.
Yeah, just note major things, then I'll be able to save and follow this. So these zeros that are before non-zero digits, these zeros are not significant. Is that okay?
Yeah.
So those zeros are not significant. They are not significant, not at all.
Yes.
We now having known that, I'm having an example here. How many significant figures is in this number 0.021?
0.021. How many significant figures are there? There are two significant figures.
Very good. 0.00787. 0.00787.
Yes, I see.
0.00787.
5 significant figures, yes.
There are 5. Which are those significant figures? Can you mention for me them?
We have the first one as 7. 0 is the second one. 7 is the third one. 8 is the fourth one. 7 is
let me read for you that one. Let me read for you that number again. It is 0.
0.
0 0
0
0
0
787.
787. Oh, they are 3. These ones are significant figures.
Good. Next. 0.333. 0.3. There are 5 threes.
There are 5 threes, yeah? Okay.
3 2.
Yes, teacher.
5 3 is followed by 5 2. Yes.
I wasn't getting you on that last example. It was 0.33.
There are 5 threes. Are you?
Oh.
There are 5 threes followed by 5 2.
Followed by 5 2, eh? Okay, I'm getting you.
How many significant figures?
3. There are 7 significant figures.
Very good. So that is all with the leading zeros. Is it okay? That is all with the leading zeros. Now we have trapped zeros. Okay?
Yes.
We have trapped zeros.
Trapped zeros. Yes.
Trapped zeros. Actually, they are zeros from the word trapped. From the word trapped itself.
Yes.
When they say you are trapped, what does that mean?
You are in the middle.
Very good. You are in the middle. Oh, you are captured. You see,
you are captured.
Yes, you are in the middle. So these are zeros which are between non-zero digits. They are in between non-zero digits, or they are surrounded by non-zero digits. That would be what we could say about this. So the trapped zeros are zeros between non-zero digits. And these zeros, do you think they are significant? For example, maybe when I have a number 205. Do you think that zero in the number in the middle there is significant? Does it? Because in the
205. The number is 205.
At the start we said significant figures are digits in a number that are reliable and absolutely necessary to indicate the quantity of something. Do you think that zero in the middle is very reliable and very necessary to indicate the quantity of that number? 205. Do you think when you eliminate that zero, does it affect the value of that?
Of course, it affects the value of this.
Then if it because if it affects, we shall say that digit is what? That 0 is significant. Is that okay?
Yes.
Trapped zeros are significant.
Yes.
So of course we know there are zeros which are in between non-zero digits, so they are significant. I want to have an example. Examples here. How many significant figures are in the following numbers? We have 4.00 73.
How many significants are there?
Significant figures. How many are there?
There are
5.
Five
We have
significant figures.
12.06.
12.06. Yes.
How many significant figures?
There are 4. What significant figure?
And then we have 0. We now have 0.00 601.
601. Yes. How many are they? There are 3.
Significant.
There are 3 significant figures.
Which are those 3 significant figures?
We have 6, 0, and 1.
Why have you left those 3 zeros in the beginning?
We have said that leading zeros are not significant. Then
very good.
dropped zeros are significant because they symbolize the quantity of something.
Good. So
yes.
that is all you needed to know about this.
Yes.
That's all you needed to know about it. The trapped zeros. Next, we have now the trailing zeros.
Trailing zeros. Roman series.
Just like this. No, sometimes in school situation, when a student is not, the performance is not all that well, then you wanted to say it in a kind way so that the student takes time to understand. Sometimes you say, hey, you're trailing. So the student, because he may not have got it well, will seem as if he's not badly off. But otherwise, when they're saying you're trailing, you're going towards the last. You actually you are tending to the last. So this trailing, but it's not a very good word to be used when it comes to performance. Otherwise, so when we talk about trailing zeros,
trailing drastically.
See, when we talk about trailing, when we talk about trailing zeros, we are meaning the zeros which are, we're not talking of the zeros which are at the right end of non-zero digits, which are at the right end
the non-zero digits
of non-zero digits. Yes. So we have so many trailing zero can be sometimes significant, and then there are cases where it is not significant. Is it okay? It is both significant and not significant, depending on the situation in which it is being used or where it is. Meanwhile, for leading zeros, we are saying they are not significant. Trapped zeros, they are significant. But for trailing zeros, it is mixed up. Take this and be very, so you be careful where it is, the situation in which it is. Now we have this. If a trailing zero is as a result of rounding off, if a trailing zero is as a result of rounding off, or calculation, you get it? Yes, if trailing zero is as a result of rounding off or calculation, is significant. If it is after Eh,
Yes.
if it is after a decimal point,
Mm.
the whole point is a trailing zero as a result of rounding off is significant. That is one thing.
Mm.
And
Yeah.
then also a trailing zero as a result of calculation is significant if it is after a decimal point. Have you got those 2 points?
A trading zero after
As a result of
after
calculation, as a result of calculation
as a result of calculation
is significant if it is after a decimal point.
is significant after a decimal point. Oh,
If it is after a decimal point.
a decimal point. Yeah.
I want to give you an example.
Mm.
You write for me this number 2.3986.
2.3986. How many significant figures?
By the
Those ones
did
are
you attend the lesson? Hold on.
Yes.
Did you attend the other lesson we had on rounding off?
No.
Did
I did.
no, but still maybe.
No. We shall go on.
So
go on, eh? And where we shall
so but no, we can capture this one now here. Well, let's have 2.3986 if we're to round these two decimal places.
If yes, 2 decimal places.
What do you get if you round that to 2 decimal places?
You get 2.40, and those
Very
ones
good.
are significant figures.
Those are 3 significant figures, right?
Yes.
Very good. You see the last zero after rounding 2.3986 to 2 decimal place, you will now have you will have what 2.40, but the number ends with 0, and that last 0 is as a result of rounding off, or it is as a result of what calculation, but it is what it is after the decimal point. So because it is after the decimal point, we'll say it is significant. Is that okay?
Yes.
So that is the first station. I hope you have got it very well.
Yes.
A zero, a trailing zero as a result of rounding off, or as a result of calculation, is significant if it is after decimal point. Basically, for calculation, it is when it is after decimal point, just it is significant. So next, we have a trailing zero, maybe that represents the accuracy of an instrument. We also talked of a trailing zero that represents the accuracy of an instrument. We also talked about this.
Represents the accuracy of an instrument.
Yes.
Yes.
You see, we say that in physics, each of those measuring instruments, they have different accuracies. Like for a meter rule, it measures to 1 decimal place in centimeters. That is the for a meter rule. Or it is 3 decimal places in meters. So each of these instruments has their own accuracies. Now, because of this, if we have an example here, suppose one measures a length using a meter rule, and you obtain values such as maybe 10.0 centimeters. Yeah? You are measuring using a meter rule, and you have obtained 10.0 centimeters. Or you have obtained 16.0 centimeters. Or you have obtained 21.0 centimeters. Because we understand that when you're measuring using a meter rule, your recording should be to 1 decimal place, and then the answers are recorded in centimeters to the unit of centimeters. So you'll find that These zeros after 10.0, I mean, in fact, this 10.0, 16.0, 21.0, these zeros found in these numbers, they are all significant. Is that okay?
Yes, it is.
Because they are presenting the accuracy of the meter rule. Yes. Maybe one time you're going to measure using a voltimeter. You'll measure maybe using a voltimeter that has a range of 0 to 5, where each division is what? Where each division is representing 0.1. Maybe you'll get maybe you'll get 2. Maybe you get 2.0 volts. So when you get 2.0 volts, you realize that that 0 is representing the accuracy of that voltmeter. So what you'll have to say here is that 0 is what? Significant. Someone is trying to call you. Can we continue?
Yes.
Okay. So we move to
reading of 2.0 volts.
2.0 volts. When you get it from a voltmeter, I was saying maybe a voltmeter that has a range of, these voltmeters are of various ranges, but there's one we have with the range of 0 to 5. This one with the 0 to 5, 0 to 6, their accuracy is 1 decimal place, and then take the measurement in volts. So I'm just saying, when maybe you have connected 2 dry cells for that circuit experiment, then you get a value of 2.0 volts.
Teacher, your voice is so low.
From the
Teacher.
Yes, please.
Your voice is very low. I don't know. I don't know what's happening.
Is it network?
98.
But are you getting me well now?
Teacher, your voice is still low. Oh, I go and I get the headphone.
You can get.
Yes, teacher.
Fine now.
Hey,
Is it
now
fine now?
You're clear, yes. Hey, we stopped
Okay.
at the
Okay.
the voltmeter.
Yes. Now, I was just saying, in short, a trailing 0 is the 0 which is at the right end of a non-zero digit. Then a trailing 0 which is as a result of rounding off or as a result of calculation is significant. If that it is in the case of calculation after a decimal point. So we said the example was when we round 2.3986 to 2 decimal places, well, we got 2.40. We said that 0 was significant. Then the second one is a trailing 0, which represents the accuracy of any instrument. We said it is significant. The example is when we measure length using a meter rule, and then you obtain values such as 10.0, 16.0, 21.0 centimeters. we are saying those zeros are significant because they have represented what? The accuracy of the meter rule. Then if you're using a voltimeter of range 0 to 5 or 0 to 6, and then you get a reading of 2.0 or 1.0 volts, or even where you're having 2 dry cells, and then you manage to get what? 3.0, which is the maximum. There we can say what? Those zeros are also significant because they have represented the accuracy of the voltimeter. Now, the last one. The last is a trailing zero, which is as a result of rounding off, or which is as a result of calculation, is not significant if it is before a decimal point. You get it?
Yes.
I want an example here. The example I have is when you round 219 to two significant figures. When 219 is rounded to 2 significant figures.
219.
To 2 significant figures.
Yes, to 2 significant figures.
This one will become, we are actually now rounding 219 so that we get 2 significant figures. This will become, because we want 2 significant figures, the first significant figure will be 1, I mean it will be 2. The second one will be the number which is next to 2, which is actually 1. But now, to get the next digit there, we are going to round the next number. Which next number is that? It is 9. We see that our preceding digit is 1, but the number to be dropped or to be rounded is 9. So 9 is greater than 5.
5, yes.
9 is greater than 5. So what we shall do is we round it to 1. So we added the 1 to the 1. So this becomes 22. But we in order to maintain the decimal place, we shall have to bring 0 to replace what? 9. So 219 will now become 220. So yes. So in 220, that 0 is now not significant. Is it okay?
It is not significant.
Yes. But it simply maintains what? The value of that number. It is there because it is maintaining the value of that number. It is not significant.
Okay.
So it is a trailing 0, but it is not significant. Have you seen where trailing 0 is not significant?
I've seen.
And then have you now also seen where trailing 0 is significant? For rounding off or for calculation, it is significant if it is what? After a decimal point. It is not significant for rounding off or calculation if it is what? Before a decimal point. But a trailing 0 that you obtain as a result of what?
Of rounding off.
As a result of reading from an as a result of reading from an instrument, which represents its accuracy, is significant. Is that okay? So that is what we have for this concept of significant figures. Unless there's something that you have not got well. But briefly, I can also use this chance to remind you about some things concerning rounding off. So in rounding off, what we do is we're actually trying to approximate a given number to a certain number of decimal places or significant figures. So in rounding off, we are approximating. You get it? The term is we are trying to approximate a given number to specific number, decimal places, or significant figures. Like for the previous examples, I've been saying you round off these to 2 decimal places. You see, we're approximating it to that number. Is that okay?
Yeah.
Then now, for us to round off a given number of decimal place or significant figures, we need to count the digits up to the figure which is in the position of the required number of decimal place or of significant figure, and then we approximate the value by applying a rule or applying some of the rules. One was that we show that if the preceding digit, if the preceding, we usually add 1 to the preceding digit if the figure which is to be dropped is greater than 5, just like what we were able to see with the other number.
With this example of 290.
Yes, if the preceding digit is greater than, I mean the preceding digit, we add 1 to the preceding digit if the figure to be dropped is greater than 5. Like for the other 2.36 something, there's that number I gave for you, example there. When we were rounding it and then you got 2.40.
Yes.
Yes. So there the preceding digit was what? 3. The number to be dropped was
9.
9. So 9 is greater than 5, so we add 1.
Yes.
Now the second one is you add 0 to the preceding digit if the number to be dropped is less than 5. Is that okay?
It is okay.
Yeah. If we add 0 to the preceding digit if the number to be dropped is 5, less than 5. And then you just know the example there. If in case of that number were rounded to 2.40, if that number was not, it was not 39, if it was maybe 34. See, yes. 4 is less than 5, then this number will remain 2.30. I mean 2.3 because I think
it would remain to maintain 3 significant figures. It would have remained that it would have remained 2.44.
2.4.
4.
So what was the number?
The number was 2.3986.
86. So to 2. Now if it was if the number, because we're supposed to round off here to 2 significant figures, if the number was now 2.3486, you get it? The number was 2.3486. See, the preceding digit there is 3, and the number to be dropped is 4. 4 is less than what? 5, so we drop it. We only drop it, we add 0 to 3. So it remains 2.3. Is that okay?
Yes.
Then the last one is if the figure to be dropped is 5. Is that okay? If the figure to be dropped is 5 and there's no digit after the 5, or there are zeros. If the figure to be dropped is 5, the example is we have 2.8. Let's have 2.85. In 2.85, the figure to be dropped, we wanted to round this to what? To 2 decimal places. I mean to 1 decimal place, not 2. We want to round this to 1 decimal place. To 1.
Yes.
We're rounding to 1.
Yes.
1 decimal place. See, the figure to be dropped is what?
The figure to be dropped is 5.
The preceding digit is
8. The figure
8.
to be dropped is 5. Since 5, if it is 5 and above, we drop 1. So it is 2.3.
5 and below. Are you sure?
5 and below, it is no 4 and below, which is 0. We drop 0.
If the figure to be dropped is 5, the case is different. Is it okay? If the figure to be dropped is 5, you see here we are supposed to now drop 5, and there are no digits after the 5, or probably be after the 5 if there were zeros. So what you do is you look at the preceding digit. Is it an even number or it is an odd number? If it is an even number, you add the 0. Is that okay? If it is an odd number, you will add 1. Are you getting what I'm saying?
If it is an even number, you add 0.
Then if it is an odd number, you now look at the preceding digit, not now the number to be dropped, because we said if the number to be dropped is now 5, you look at the preceding digit. If it is an even number, and then you add 0. If it is an odd number, you add 1. Meaning that if we now have 2.85, this will now become 2.8. Eh?
2.8.
Is it okay? What about if you have 1.95?
1.95.
For 1.95, you will drop the 5, but you add the 1. Then to one decimal place, this becomes
2.0.
Very good. Very good. That is how we just go about with this. Is that okay?
It is okay.
Those actual summarize. Those summarize rounding off. I want us, and then maybe the last one is here. If the figure to be dropped is also 5, and there are other digits after the 5. For example, you have 0.452. This is to be 452. You have to round to one decimal place. See, the figure to be dropped is what? Is 5. The preceding digit, but there's a figure after the 5. If there's a figure, none other than zeros after the 5, what you do is what? You will add 1.
You will add 1.
So what will be that one? If you round to 0.
To one decimal place. 0.5.
Very good. So that is all with the rounding off. Is that okay? So we have looked at the concept of rounding off and the significant figures. These ones, you must remember them. So next time we are going to meet, I'll give you, next time we are going to meet on this, we shall look at constants, non-measured values, and then trigonometric ratios, and probably maybe roots of numbers. And then we shall stop there. Then next, after that, we shall move to how to record data in the main table of values. That is how we shall be able to proceed with this.
So this lesson is for physics practical?
This one is for physics practical. The background to physics practical, it is the theory. This is But on the other side, I said we shall also be looking at what? I've given for you the link where you're supposed to read the light.
The light.
I don't know if you're already reading that. We shall have a live lesson like this where I will be able to take you on a few areas that you don't get. But otherwise, I just no, those areas you can be able to get by yourself, because we have a lot of interactions, a lot of interactive activities from those lessons on the site there. You can even move on with it on your own. But where you get stuck, you get to me.
Like, can we do it? Can we like connect and we do it like both of us?
Meaning?
Meaning that can we go through it like both of us?
That part of light.
Like, okay, if we get like a unit, can we go through it like both of us? And
no, I will go over, but I'll be going very fast, of course. But I want you to, like, you go and you read ahead, you see, because our lessons, our notes we have there, we have summarized them in a way that they're very clear, and where you just get stuck, even you can instantly get to me, can say I am stuck here. If you are reading, I can get to you on a phone call. Is it okay? I guide you. Where it is beyond that, we shall have to sit for, arrange for an engagement like that. I mean like this one here, and then we move on together.
Okay.
Yeah.
So when are we again meeting?
Anytime. So for us, we can just meet anytime. But I always inform you. I will inform you one day ahead. I'll inform you one day ahead. But I will give you task there to always do it. I mean, when I give you task, you need to do it, because if I give you task and then you don't do, when we come for the next lesson, my preparation for the lesson will be that you already have done it. Then you see, we shall not be moving on well.
Okay.
Yeah.
So can
Okay.
you,
So
okay, like meaning that can I tell you and we organize like in any time
yes, that is okay.
a live lesson?
Yes.
Okay. Okay.
So so have a very good evening.
Teacher, can we meet tomorrow?
Tomorrow.
Oh, you're busy. You're busy.
No. Okay, let's get to our let's get to chat. I'll be able to get back to you there. Okay.
Thank you, teacher.
You're welcome. Herman, are you there?